Hey guys, today we're going to do some curve sketching. Just to let you know up front, there's a lot of information in this video, so you may have to watch it a couple times. There's two parts to this. We're going to sketch this fraction, and we're going to list what I call essential elements of graphing. So let's first find 4 or 5 of the main elements in order to sketch it. The first thing you want to do is see if there's something called a hole in the graph. What that means is there's an undefined value that the graph will kind of skip over. So to figure out if there's a hole in the graph, you have to factor the numerator and denominator. So the denominator is the difference of two squares, x minus 1 times x plus 1. The numerator breaks down to 2x plus 1 times x minus 1. And what we try to find normally is what's called a vertical asymptote. So I'm going to first try to find possible vertical asymptotes. Now that's a fancy phrase for an undefined value. We'll say undefined x value. So to do that, all you do is set the factors in the denominator equal to 0, because a fraction is undefined when the denominator is 0. So we'll set x minus 1 equal to 0 and x plus 1 equals to 0, because those are the factors in the denominator. So 1 and negative 1 are the undefined values. But notice how I use the word possible, because the x minus 1's cancel and the x minus 1 produced a 1. The 1 is actually a hole in the graph. So again, when factors cancel, instead of this value that made this denominator factor 0 be a vertical asymptote, it's a hole. Now this x plus 1 is not canceling, so negative 1 is where there's a vertical asymptote. So we can start building our sketch over here on the side. We know at negative 1, x equals negative 1, there's a vertical asymptote. The hole, we have to find out where to locate it. It's kind of like a point, but with an open circle. What we're going to do is we're going to take our fraction and plug this 1 into it. But we're going to plug it into the canceled fraction. So let's do f of 1. And again, the canceled fraction is x plus 2x plus 1 over x plus 1. So if I plug 1 into this, it's 2 times 1 plus 1 over 1 plus 1, which is 3 halves. So 1 comma 3 halves is the hole in the graph. So that would be like 1 3 halves, somewhere right there. So we should label that. Okay, next, now that we have our vertical asymptote in our hole, we need to find out where to hang this graph. So let's find the x-intercept. So to find the x-intercept, any value on the x-axis has a y equal to 0. So what we do is we're going to let y equal 0. And think about it. When you cross the x-axis, y is 0. So we're going to let y equal 0. So this is going to say 0 equals 2x plus 1 times x minus 1 over x minus 1 times x plus 1. We need to solve this to find out where the graph hits the x-axis. So the first thing we do to solve this is we want to get rid of this division by these factors. To undo division, you multiply. So these all cancel. 0 times anything is 0. We're going to set these factors equal to 0. And solve. 2x plus 1 equals 0. And x minus 1 equals 0. So this will come out to be negative 1/2. And this will come out to be 1. Now keep in mind, x equals 1 is a bad value. There's a hole there. So that can't be an x-intercept. But this negative 1/2, this is a fine value. It's like right here. Negative 1/2, 0. So far, what have we done? We factored the problem. We know that since these factors are canceling, that's where there's a hole in the graph. We know the leftover factor produced a vertical asymptote. And we found a point in the graph. The x-intercept is when y equals 0. Next, we should find any y-intercept. So a y-intercept, where we cross the y-axis, is when x is 0. 0, 1, 0, 2, 0, 3. So if we let x equal 0, we simply just plug 0 into the original question. So f of 0 is 2 times 0 squared minus 0 minus 1 over 0 squared minus 1, which is negative 1 over negative 1, which is 1. So 0, 1 is our y-intercept. And the last thing we need to find in order to sketch the graph is called a horizontal asymptote. A horizontal asymptote is a horizontal line where the graph gets really, really close to, far, far away from 0. So what we do is we plug in a huge number. So let's plug in 10,000. So 2 times 10,000 squared minus 10,000 minus 1 over 10,000 squared minus 1. So if you plug in a really big number, let's see what's happening here. When you plug in this really super big number, you get, think about what you get. Jen.
Yes.
You get approximately 2. Think about it. This numerator is about, well, if you're plugging in a really, really big number, this 10,000 minus 1 is not important. So this is approximately 2 times 10,000 squared over 10,000 squared. So these are going to cancel, and the answer is approximately 2. So again, you're not really concerned what this answer is. You're trying to see what it's approximately equal to. So the easiest thing to do is plug in a really super big number, and just look at your calculator or just think about it. These last few terms really don't matter. The numerator is double the denominator. So y equals 2 is a horizontal line that we're going to get really, really close to, far, far away. That's what we just discovered by plugging in 10,000. 10,000 is far away. So we know that we're going to get really close to that eventually. So basically the graph gets close to these asymptotes. If you think about what's happening on the left side of negative 1, plug in like negative 2, negative 3, it's going to get really, really close to positive numbers. So what typically happens is on either side of this vertical asymptote, one side goes downward and the other side goes upward. So that's what the graph looks like. Now all we have to do to finish this off is list some important elements. So let's list where the graph is. Maybe I'll put these side by side. Let's list where the graph is increasing and decreasing. So we have the graph right here. So our fourth element will be where is it increasing. It's increasing if the graph is going upward when you read left to right. So this section is going upward and this section is going upward. You got to be reading from left to right. So we're going to say from negative infinity to negative 1, the graph is increasing. From negative 1 to 1, we got to stop at this hole. The graph is increasing. And from 1 to infinity, the graph is increasing. Where is the graph decreasing? Well, it's not. Even though this arrow is pointing downward, you have to read from left to right. Decreasing means as you're reading from left to right, the graph is going downward. It's never going downward. So you could write never, or you could just put like empty set. Let's talk about the shape of the graph. Where is the graph concave up? Concave up, it looks like a cup. The opposite of concave up is concave down. Concave down, it looks like a frown. So you just look at the shape. This section's concave up because it looks like a cup. This section's concave down. So it's concave up from negative infinity to negative 1, and then also from negative 1 to 1, again, skip over your hole, and then from 1 to infinity. Now, if the graph ever changes concavity at a point, it's called a point of inflection. So what that means is, if the graph is concave up and then bends to be concave down, this point where it changes would be a point of inflection. And sometimes you can't really tell what it is on the graph, so you can make a good guess. On our graph, it does change from up to down, but it's not at a point. It's on either side of a vertical asymptote. So we're going to say none. And by the way, it could also be concave down to concave up. These are both points of inflection. And the last couple of things, we're just going to list the domain, which are the possible x values, and the range, which are the possible y values. So the possible x values, if you read from left to right, is everything except for this vertical asymptote in this hole. So I'm simply going to write x cannot equal negative 1 and 1. The range is how high and how low the graph goes. That's everything except for 3/2, where the hole is, and 2. So I'm going to say y cannot equal 3/2 and 2. So watch the video over and over and over again and really concentrate, take some practice, come onto the Google Meet and ask questions, and have a great day.